Usually in coastal navigation, we consider that we are on the surface of a sphere and we navigate mostly by using terrestrial objects and aids to navigation in the sea. Everything has a unique geographical location that we express in degrees north or south of the equator and east or west of the prime meridian. The equator is a great circle that runs east to west around the Earth. The prime meridian is a great circle that runs north to south around the Earth. Lines of latitude run parallel to the equator and are named according to the angle between the line and the equator at the center of the Earth. Lines of longitude or meridians are all great circles, all passing through the poles, and are named according to the angle between the meridian and the prime meridian at the center of the Earth. The poles are the true north and south poles. When we navigate with celestial bodies, we must change our perspective from being on the surface of a sphere to being in the center of a sphere. When we look up at the sky, especially at night, as navigators, we are seeing the inside ceiling. Our position in the sky is a dot directly over our head, called our zenith. So our geographical position, in latitude and longitude, can be projected onto the celestial sphere as our zenith. Just as we projected our position to the celestial sphere as our zenith, similarly we can project the prime meridian to the celestial sphere. Now our zenith is the same amount of degrees from the prime meridian as our longitude. So celestial bodies each have a celestial longitude called its Greenwich hour angle, or GHA. Just as we projected our position to the celestial sphere as our zenith, similarly we can project the equator to the celestial sphere. Now our zenith is the same amount of degrees from the equator as our latitude. So celestial bodies each have a celestial latitude called its declination. The nautical almanac tabulates the GHA and declination for the Sun, the Moon, the planets, Venus, Mars, Jupiter and Saturn for every hour of every day. Trinidad is located on Earth. Earth is rotating once every day. Earth is revolving around the Sun once every year. The tilt of Earth's axis affects Trinidad's distance from the Sun at different times of year. The Moon is revolving around Earth in an elliptical orbit, varying the distance the Moon is from the Earth at different times of a month. All of that motion means that the finite section of sky over Trinidad sees celestial bodies rise, pass over our meridian and set. The nautical almanac tabulates the time of sunrise and sunset for each of a range of latitudes. One time of sunrise and sunset are given for 3 days. The nautical almanac tabulates the time of moonrise and moonset for each of a range of latitudes for every day. Trinidad is on the meridian 61 degrees 30 minutes west. The nautical almanac tabulates the time that the Sun, Moon, Venus, Mars, Jupiter and Saturn passes over the prime meridian for every day. Here are some approximate distances from Earth to celestial bodies. A GPS satellite is 20,000 km from Earth, the Moon is 384,000 km, Venus is 74 million km, the Sun is 150 million km, and Polaris is 400 plus light years from Earth. Navigation calculations are more involved when the celestial body is closer to Earth. Atmospheric refraction is the deviation of light from a straight line as it passes through the atmosphere due to the variation in air density as a function of height. Astronomical or celestial refraction causes astronomical objects to appear higher above the horizon than they actually are. The nautical almanac tabulates the GHA for Aries for every hour of every day. Aries is a benchmark in the sky that revolves around the Earth at the same speed as the stars. The nautical almanac tabulates the sidereal hour angle, SHA and declination of over 50 named stars including Polaris, the North Pole star. The nautical almanac shows that the stars, because they are so far away, barely change their positions relative to Earth's equator and Aries. The daily sidereal hour angle of the 4 navigation planets is given in the almanac. The planets are much closer to Earth than the stars. The planets are elliptically orbiting the Sun, at varying speeds. The SHA and declination of planets vary significantly from day to day. We will need to use the longitudinal angle between our zenith and the celestial body, That is called local hour angle, LHA. While it is convenient to have multiple stars to take sights with, star sights can only be done when both stars and the horizon are visible. This happens at twilight, when the sun is rising and setting. The nautical almanac tabulates the times of nautical and civil twilight for morning and evening for each of a range of latitudes. One window for morning and evening twilights is given for 3 days.